Hey guys, and welcome to the Python Crash Course. The goal of this tutorial is to provide you with a solid foundation in the fundamentals of the Python programming language. We'll be covering all the basics, including how to install Python, how to set up a new project, and how to write and run code. We'll cover Python syntax, including variables, data types, functions, data structures, and much more. We'll also do some exercises and a few short projects to reinforce the knowledge and make sure you're comfortable with the concepts. By the end of this course, you should have a firm grasp of the basics of Python and be well positioned for exploring more advanced concepts and also working on Python projects going forward. This tutorial should be helpful whether you're completely new to programming or coming from another language such as JavaScript. So without further ado, let's get started. Python is a high-level language that's specifically designed to be easy to learn and use with an intuitive and highly readable syntax. If you have experience with another programming language, chances are a lot of this will look really familiar. And if you don't worry, we're going to cover everything from the ground up. Python can be used in a number of different applications, including task automation, command line interfaces, web and REST APIs, blockchain smart contracts, and games, just to name a few. So it's a great language to learn because it's not limited to any one domain. It's also very popular in AI, machine learning, and data analytics. So Python's a great choice for all of these reasons, not to mention it's in extremely high demand in the job market. Alright, so before we do any coding, we'll need to download and install Python if we haven't already. Now if you're not sure if Python is installed on your machine, here's how you can check. Now I'm on a Windows machine, so what I'm going to do is open up the command prompt by typing in cmd into the search box. Okay, now if you're on Mac, you'll basically do the same process, except you'll open up the terminal. Alright, now once that command prompt opens up, I'm just going to type in python space dash version, and that should either give me the version number if Python's installed, or this message saying Python was not found. Okay, so in my case, I don't have Python installed, and what I'm going to want to do is go out to python.org/downloads and download the latest version. Okay, so 3.10.6 is the latest version as of today, so you'll want to go ahead and download that for your operating system. In my case, it's Windows, so I'm going to click on the Windows and go ahead and download the installer. Now, if you have an older version of Python, Python 2.x, I definitely encourage you to download the latest, Python 3, because there are significant differences between the two versions. Alright, so I'm going to download the Windows installer for 64-bit. Okay, and once that downloads, I'll go ahead and double-click on that to run it. Alright, and let's see, I'm going to click Add Python 3.10 to Path. I'll leave this one checked, Install Launcher for all users, and I'll click on Install Now. So this should just take a couple of seconds to go ahead and install. Alright, so the installation process is complete, so I'm going to go ahead and close this window. And what I want to do is probably close out of my command prompt and open it up again. Now that Python's been added to the path, I should be able to get the version here. So let's try that again, python --version. And great, now I've got Python 3.10.6 installed, so that is the latest version. Now another thing I can do is just type in Python in the command prompt, and you see these three arrows. So this is actually the Python interactive shell, and I can actually run Python code directly on the command line right here. So I'll just do a simple 1.1. This is actually Python code, and as you can see, I get the result here too. So I just wanted to show you that while it was open here, that is something you can do, just simply run Python code directly in the command line interface. So definitely make sure that you've got a version of Python 3 installed. And by the way, if you want to get out of this, you can do exit and parentheses. You can also do quit parentheses. Now, depending on where you've installed Python from and what previous versions you might have installed on your machine, sometimes this will be Python 3 So you can try that. It's not going to work for me because since I had no previous versions installed, it just installed it under Python. But it may be the case that yours is installed under Python 3. I've even seen it installed under like Python 3.10. So just be aware of that. And when in doubt, you can just always go ahead and download and install the latest version. All right, so now that Python's installed, it's time to choose an IDE to use so that we can start writing code. An IDE is basically, it stands for Integrated Development Environment, and it's basically a desktop program that helps you write and organize your code. So for this tutorial, you can use any IDE that you like. A lot of people use PyCharm, and then Visual Code is another very popular one, and that's what I'm going to be using. That's what I recommend, but it's totally up to you. So what you can do if you don't have Visual Studio Code is, let's see, Visual Studio Code download. Just very simple install process. You just want to find this. It'll probably be the first result here, and then just download the installer for your operating system version. All right, so now once Visual Studio is installed, you can go ahead and pop it open. And I didn't show the entire install process, but basically it's very straightforward. If you just select all the defaults, you'll be just fine. So go ahead and create a folder somewhere on your machine to work in for this tutorial. And then once you do that and open up Visual Code, I'm going to go ahead and select Open Folder. And I'm going to, let's see where to go. There we go, Python Crash Course, so I'm going to open up that folder. All right, so what we're going to do is we're going to start writing our first Python program. Before we do that, though, I just want to do a little bit of setup. So on the left-hand side of the screen here, you'll see something called extensions. Looks like a couple of squares over here. And we want to install an extension for Python, just so we get some IntelliSense and syntax highlighting that'll help us in coding. So I'm just going to go ahead and do Python, search for Python, and this is the one I want. It's the very first one in the results, Python, IntelliSense, Pylance, etc. So go ahead and click Install. All right, so now that that extension is installed, let's go back over to our File Explorer view and go to your top level folder, and let's create a new folder for our Hello World program. So I'm going to create a new folder. Call it Hello World, okay? Now inside that folder, let's create one new file, and we'll say hello_world.py. All right, so a couple of things to notice here. This lowercase with the words separated by the underscore, that is a very common Python convention. So it's very readable. So we'll just try to get used to that sort of formula for creating new files. The py extension, obviously Python extension, that lets Visual Code know that this is a Python file, and so we get our IntelliSense and syntax highlighting. All right, so let's go ahead and open up that file, and I'm going to write print parentheses. Now in quotes, this could be either single or double quotes. We'll say hello world. Okay, I'll go ahead and save that. Now this is our first Python program, so there are a couple of different ways we can run it. We can go up to the Run menu here, Run without debugging. You can see that there's a keyboard shortcut, Control F5. Okay, and that'll open up the terminal and display the output. And there we go, there's our Hello World text. So there's a couple of different ways to run code here. That is one, just through the UI. We can also simply type Python space and the name of the file, helloworld.py, and then hit enter. Oops, and if we get that error message, that means that we are not in the correct folder location. So I do ls to see the folders here and cd into hello world. Oops. There we go. Okay, now let's try that again. Now you can simply press the up arrow on your keyboard. Press it a couple of times until you get back to that Python hello world. Hit enter again. And there we go. There's the output of our program, which is the hello world text. All right, so that was easy. Congratulations. We've just ran our first Python program. All right, so before we go any further into coding, I just have one more setup item I'd like to cover. And this has to do with indentation and spacing. So in the Python language, indentation is really important. It takes the place of brackets in a lot of cases, well, when compared to other languages. So for example, you want to make sure you hit enter here in your code and you're able to hit tab and have that equate to 4 spaces. Okay, so basically, tab should equal the same as 4 spaces. Now in Python, when you're writing your code, you don't want to mix tabs and spaces. All right, so what you can do, there's a setting in Visual Code. Now you also don't want to have to hit the space bar 4 times every time you indent, right? So you want to be able to use the tab key, but have that actually insert 4 spaces. So what you can do is go to settings, and this may be already set by the default, depending on how you have things set up. Like if you've just done a fresh install of Visual Code and you've installed the Python extension, it's probably set already. But here's how you can check. So I'm just going to search for indentation and look at text editor. So where is it? If I scroll down a bit. Okay, so this is what I'm looking for. Editor insert spaces. So insert spaces when pressing tab. So you want to make sure that this is enabled, okay? And then you want to make sure that your editor tab size is set to 4, which is the standard for Python. So again, if you've just installed a fresh copy of Visual Studio and install the extension, this is probably set by default. If not, you can go ahead and create this setting, and you can just test it out in your code by hitting enter and then tab, and make sure that looks like 4 spaces, All right, so one other thing, and I kind of ran into this problem early on. If you also use Visual Code for another language, such as JavaScript or TypeScript, you may be used to using 2 spaces for indentation instead of 4. So if that's the case, as it was for me, there's a way that you can target a specific setting only for Python. And here's how we can do that. So I'm going to go to View, Command Palette, and I'm going to search for settings, and what I'm looking for is right here, Open User Settings JSON. And so this is basically a JSON representation of the Visual Code settings, just to give us a little more fine-grained control. So I'm going to add a comma to the last line here, and I'm going to start a new line, and I can do quotes in square brackets. I'm going to write Python. So this means that basically what I'm going to type further is specific only for Python. All right, so we'll do colon, curly brackets, and I'm going to do editor dot, and we can see some IntelliSense kicking in, so maybe it'll help us find what we're looking for. Insert spaces, true. Okay, and one more setting, so I'm going to do editor dot tab size. Tab size, there we go, and we'll set that to 4. Okay, so go ahead and save that. All right, you can close this file now. And so we can check just to make sure that that is actually working. So I'm going to go back up to the first line here, save my file, and let's just say that we want to set the default to 2 because we work with JavaScript a lot. All right, so change that to 2. Now, if everything's working correctly, it should still be 4 because it'll recognize that this is a Python file. So enter, tab, and there we go. So we still have 4 spaces, even though the default is 2. All right, so with that setup and simple hello world example out of the way, here's where the fun really begins. We are going to dive into the core of the language, starting with variables and basic data types. So what are variables? Variables are placeholders for data that's stored somewhere in your computer's memory and used in your program. Variables have 2 parts, basically a name and a value. The value is actual data, and the name is a label that's attached to that data that we can use to reference it in our program. So here's how we declare a variable in Python. So let's say I want to modify our Hello World program to print out my name as well. Hello, Jonathan. So I'm going to declare a new variable, and name is the name of the variable, and here's the actual data. So this is known as a string, which is just textual data, and we can designate a string by using either double quotes or single quotes. So they both work just as well. Now, inside my print command here, I can use a plus symbol and the name of the variable. Okay, let's save that and run it. And you can see we get hello Jonathan. Now, pay special attention to this syntax here. We have a string, because we've got double quotes, then the plus symbol and the variable. Okay, and this is known as string concatenation. We're taking a string literal, which is a string that's typed directly into the program, and adding a variable name to that, and the output of that is one final string, hello Jonathan. Now, there's another way that we can combine our variable and our greeting string here, and that is to use a special type of string called an f-string, or formatted string. And here's how that looks. So we'll start with a lowercase f, whoops, too many parentheses there, okay, to indicate that the following is going to be a formatted string. And here we have hello space. Now inside this string, we can add the name variable inside of curly braces, just like that. All right, so that makes it a little bit more convenient to write. We don't have to worry about the plus sign and the kind of awkward space within the hello string. So save that. Let's run our program again. Again, I'm just going to hit the up arrow to go back to our Python command. And there we go, hello Jonathan. Now you can imagine if you have a longer, more complicated string that's maybe using several different variables, this can be a better format than the string concatenation. It just makes it a little bit more clear to see where the variable is and where the string literal is within the program. And I just want to point out that typically when you're programming, you should stay consistent whether you choose single quotes or double quotes. So I'm going to go back and change this to double. Just good practice to be consistent throughout the program. All right, now just a word about variable naming conventions. It's typical in Python to use lowercase, and it's totally fine if your variable is 2 words, like let's say this is first name. But you want to separate words with an underscore, just like that, similar to the rules we followed for the file name. So let's say I had a last name as well. So I'll use lowercase separated by an underscore. Okay, and I'll type in my last name there. Oops. And I see some red out of the corner of my eye. What's going on here? Okay, I'm just going to clear that. All right, and I think it's complaining right here because now I've changed the variable name, so I've got to change this to correspond with that. Okay, and so now I can add my second variable as well. So I'll say last name. Okay, and let's run our program. Save the file, of course. And I'm going to go back up and search for our run command there. Okay, great. Now, with string variable types, or string data types, I should say, there are a number of built-in functions that we can use. So let's say that, because sometimes this is helpful because this may be user input, which is unpredictable. And let's say the user typed in their name lowercase and we want to display it as uppercase. So what I can do is do a dot, and we start to see some IntelliSense here. Okay, so we can call firstname.upper and lastname.upper. Okay, save that, and let's run that and see what the output looks like. So now we have the whole word, the entire string, uppercase and lowercase. And then we can also use .lower to indicate lowercase. Let's say if this was all uppercase or a mixed case, and we wanted to normalize it to lower, we could change this to lower. There's another useful function, which is title. And can you guess what this does? Basically, it's going to format it as if it were a book title, you know, first letter uppercase and the rest lowercase. So let's try to run this and see what happens. And there we go. And that's more of a sort of normally formatted first name, last name. So there's another function that we can use that will strip white space. Let's say the user typed in the first name with a bunch of white space. All right, now let's just run this code again and see what it looks like. And I'm guessing it's going to look ugly. There will be a bunch of white space in between the names. Yeah, so let's say we want to normalize this and remove any white space that the user may have added. Okay. So what I can do is use another function called rstrip, and I can go ahead and chain it onto the end of this. And there we go, rstrip. And I'll do the same here. There we go. Save the file and let's run that again. And there we go. Now it's removed that white space and it's also normalizing the capitalization. All right, just wanted to mention quickly before we move to the next section about comments. So you can write comments in Python by using the hash symbol. And then let's say I wanted to describe what this function is doing. Print a greeting message. Okay, so this essentially is ignored by the Python interpreter, but it's visible in the code, so it's a good way to annotate or describe what code is doing. All right, let's move on to numbers. So the two main number types in Python are integers and floats. And I'll just reconfigure our example code here so we can work with some numbers. So an integer may be something like 10, as well as negative numbers, -5, let's say. Okay, and an example of a float would be any number that has a decimal place, like 5.2. Now we saw before that we can use arithmetic operations such as addition. Okay, oops. So we can use the variable names here. So I'm going to say first number plus second number. There we go. And let's print the result of that. And I'm going to use a keyboard shortcut now to run our code. So I'll say Control F5. And there we go, 15.2. Okay. Now we can try out some other operators here. We've got subtraction. Okay. We've got multiplication, which you can use the asterisk here. And notice that it's outputting a 52.0. So when you combine a integer and a float, the result's always going to be a float. So what if we change this back to just 5? So now we're dealing with two integers. It should just show us the integer result. There we go, 50. Okay, and division, we just use the slash, // All right, 2.0. And you may be wondering why the result is a float here, even though we've started with two integers. Well, the result of a division operation in Python is always a float. It returns a float every time. We can use two asterisks to show a power of operation, 10 to the power of 2. Okay, and let's look at those results. So 10 times 10 divided by 5. In other words, 100 divided by 5 is 20. Okay. Now sometimes in programming we have one variable that holds a certain value. Let's say x equals 5. And let's say maybe this is, let's change it to make it a little more realistic, 50. Let's say this is the result of a dinner bill. So the bill is $50. Now sometimes we want to create a new variable or use the same variable to add a certain number to whatever the existing value is. So in this case we could say x equals x plus, and let's say there's a service fee of $10. Okay, and then we'll output x. $60. Okay, so we're saying x equals whatever x already is, which is 50, plus 10 more. Now there's a shorthand way to do this, because this is a pretty common task in programming. We can say x plus equals 10, and that means the exact same thing as x equals x plus 10. And if we save that and run it, we should get the same result. There we go. So just something to keep in mind to make your code a little bit more cleaner and more concise. All right, there's one more thing I wanted to point out about numbers before we move on to the next section, and that is when dealing with large numbers, such as 1 million and let's say 10 million. One thing we can do to make this a little bit easier to read is use underscores. And so we can place some underscores where you would normally use commas in typical notation. And this won't affect the actual number or the result. It just makes it easier to read. So let's see, I'm starting with 1 million and I'm adding 10 million to that. So what should the result be? 11 million, right? And there we go. So we get 11 million just as we would expect. Another important variable type in Python and in all programming languages is called the Boolean value. So a Boolean value is simply a value that represents whether something is true or false. So let's say, for example, I wanted to create a variable that represents whether a user is logged into the system or not. So I can say is signed in equals false. Usually when you first visit a site, you are not logged in, right? And then, oops, we may have some logic later to actually log in the user. Log in user. Okay, they have to enter their password, their username. And then we set this flag to true. Oops, equals true. All right, now notice that I am using uppercase false and uppercase F and T with the Boolean values. So this has to be uppercase or lowercase. If it's not, then the interpreter will not know what it is. It'll think it's looking for some variable or something. So let's clear this and let's go ahead and do Control F5. And we get a true value. Okay, so the user is logged in. Just for fun, let's try to change this to lowercase and see what happens. So first of all, we already get a cue that something's wrong with the IntelliSense. And if we run the program, it'll give us an error. Yeah, name error, name true is not defined. Did you mean true? So it's already sort of able to guess that what we intended to do. But really it's thinking true is some other variable name. It doesn't know what to do with it. Okay, so make sure that your trues and false and your booleans are capitalized. All right, now there's one more variable type that I want to talk about, and that is something called a constant. So a constant basically is a variable that you don't want to allow to have a value reassigned to it once it's been assigned in the first place. So you can imagine maybe that we've got let's continue the sign-in allegory here. Let's say we want to have a max attempts. So we only want to let the user to try to sign in 3 times or something like that. So this is sort of a global variable that's never going to change throughout the lifetime of the program. All right, we'll call it max attempts. Now you notice that I'm using all uppercase here for this variable name, and that is a convention in Python that the constants should have all uppercase. So just so it's kind of a visual cue, so it's easier to identify a certain variable as a constant. And there we go, max attempts 3. Now, so the idea with constants is that they shouldn't be reassigned. However, little secret is that in Python you actually can. So there's nothing about the Python runtime that will prevent you from doing this. So it's not strictly prohibited. So that's why I said it's more of a convention. Constants are more of a convention. Really, they're just regular variables. But we sort of agree as a Python developer community to use uppercase, and that means that you shouldn't reassign the value to this variable. So if I run this again, we'll see that it will in fact allow me to reassign it to 4. So anyway, it's just something that you should be aware of in your coding, and if you see all uppercase, or if you don't intend for a value to change, use all uppercase to indicate a constant. All right guys, so next I want to talk about how to gather user input. So let's say we're building a command line interface and we want to have the user enter some information and we will display it back to them. All right, so to do that, we can use a built-in function that Python comes with called input. Okay, input, and then we can use parentheses to, enter in a string question or something like that. So let's say, hello, what's your name? Okay. Now you notice that I've got an apostrophe within this string, and so I definitely want to use double quotes here. Normally we have the choice to use single or double, but look what happens if I change this to single quotes. Then it's not understanding because it's thinking this apostrophe is the end of the string. So this is a case where you definitely want to use double quotes. All right, so hello, what's your name? And that's going to run, and then I can enter in my answer here, press enter. Okay, now we're not actually doing anything with the answer now, so how do we capture that input, that user input, to use in our program? Well, the result of this input function returns a string, and so we can set that to a variable. So let's set a variable called first name, okay, and then let's echo that back. Oops. And so let's add some sort of message here. Let's just say hello, first name. So if you remember before, we could use a formatted string. And then we can use curly braces to hold our variable. All right, so let's try to run this code again. Control F5. What's your name? Okay, and I can type in Jonathan. Hello, Jonathan. Okay, so you can see we kind of have one full back and forth round trip interaction here. We're able to capture the user input in this variable and then use it in our program further. All right, so let's add another variable here. Age. Okay, so let's say how old are you? Okay, and then all right, let's keep our flow intact. So I'll actually put this print right here, and then we'll print another message after we capture the age. Okay, so I'll say, so we use a formatted string again. So we'll say name is age years old. Okay, and I'll save that. Let's see, what is this complaining about? Oh, first name, right? See, that's good. We got the IntelliSense to alert us that our variables weren't matching up there. All right, and let's do Control F5. What's your name? Jonathan. How old are you? Okay, I'm going to say I'm 99. Jonathan is 99 years old. There we go. So we can kind of see how we can solicit user input and then use it and manipulate it in our program. All right, so let's say we wanted to write a program that calculated the total, including the bill and any additional tip that the user might want to add. So how do we do that? So we might have a variable to hold the total of the bill. So let's just say bill, and maybe we'll set that to $20. We'll just say 20. We'll make it an integer. Okay, and then we can calculate we can gather the tip amount from the user by using input. So we might want to echo the bill total, like maybe we'll use a formatted string and say your total is. We add a $sign there, and we'll say bill. We say, would you like to add a tip, or how much would you like to tip? Okay, we'll assume they're being nice and they want to add a tip. And so then we can calculate the total, right? We can say total equals bill plus tip, and then sort of output the total. So I'll say print the total is, and we'll say total. Oops, and I forgot my formatted string indicator. So we'll just add an F right here. Okay. All right, so take a minute to look at that and make sure that's all understandable. So what do you think the total is going to be in this case? Let's run the code and find out. The total is $20. How much would you like to tip? All right, I'm going to say 5. It was really good service, so that's a 25% tip. So we have an error here. Okay, and what is it saying exactly? Type error, unsupported operand types for int and string. All right, so do you see what's kind of happening here? We're mixing two different data types. The bill, 20, that's an integer, right? Because there's no decimal, so it's not a float, it's an integer. And then remember what we said about the input function, it's always going to return a string. So even though the user typed in 5, like the numeric value 5, it's actually coming back as a string. So here, when we're tallying up the total, we're mixing two types. We're mixing an integer and a string, and the interpreter doesn't know how to deal with that because it can really only add two of the same data types, right? So one thing we can do, and this is a very common thing that comes up in programming, where we want to change or convert one variable type to another, and it's called casting. All right, and so in this case, there's a way that we can cast a string value to an integer. And what we can do right here, where we have tip, now remember this is a string, we can call the int function, okay, and this will convert the string to an integer. So if we save that and run it again, let's see if that fixes our problem. I'm going to say 5. and your total is 25. All right, so now the variable types are in agreement and we're getting the result that we would expect. All right, so we can go from string to integer by calling int. Now we can also go the other way around. Why don't we try that? We'll try converting bill, which is an integer, into a string. Oh, sorry, it's str. Okay, save that, and let's see what result that gives us. All right, so I'm going to say the same thing, 5. Your total is 205. Okay, so our variables are in agreement again. Now they're both strings, and so instead of 25, we're getting 205. And the reason for that is because the plus here is now, it's not an arithmetic operator, but it's a string concatenator operation. So in other words, we're taking literally, we're literally taking the string value of 20 and adding the string value of 5, and that's giving us the string value 205. Okay, so although that conversion worked, that's not what we want. So we want to stick with the previous version where we cast the string to the integer. Okay. Another thing you can do is you can cast something to a float as well. All right, and this shouldn't make any difference, I don't think. Let's try this. Let's see what happens here. And I'll say 5. Yeah, so basically the same result, 25.0, since this is now a float. All right, guys, so before we move on to the next section, I'd like to take a quick break for our first coding challenge. So here's the coding challenge. What I'd like you to do is create a new project folder and a new Python file, and then you are going to create a program in Python for an auto sale ad. Okay, so you are going to collect some information from the user first, and that information to collect is the make, model, year, and price of the vehicle. And once you've collected all that information, then I'd like you to just print a one-sentence description of the car sale ad to the console containing all of that data. Okay, so make, model, year, and price. So some of the things that we've learned that you'll have to use in this program are variables, collecting input from the user, and formatting strings to output both string text data and variable data. Okay? All right, so feel free to ask any questions in the comments below or share your code there as well. And if you'd like to take a look at the answer key or the answer program, you can find that in the GitHub repo for this tutorial, which I'll link in the description of the video. All right, so we are moving on to the next section, which is on conditionals. So conditionals really get to the heart of programming. This is where decisions get made in your code. So very often in programming, we want to check for a certain condition in our code, for example, to see if a variable holds a certain value, and then execute code conditionally based on the result of that check. For example, we might want to see if a user is logged in and display a certain web page or message based on that. Okay? So in Python and many other programming languages, we can express this kind of logic with if statements. All right. Now I've created a new folder here called Conditionals, and I've created something called weatherapp.py to sort of test out some of this logic. All right, so let's say we're building a weather app and we want to print out a message. Granted, this is a little bit subjective, but to say whether it's hot, cold, nice outside, etc., based on the temperature. Okay. So let's say we have a starting temperature value, and I'll say it's 90 degrees. Okay, so this is sort of our global variable that holds our temperature for today. Okay, so now in my code, I want to check this value basically and print out, either it's hot or it's cold based on that value. So I can use an if statement. Now let's say, again, this is a bit subjective, but depending on where you're from, let's say if the temperature, and if is a keyword in Python to start this conditional statement, okay? If temperature is greater than 80, then we want to print a certain message. Okay, so it's very important here to pay kind of attention to the structure here and the layout of this, because this is really important in Python. And I touched on this a little bit earlier when I talked about indentation. All right, so to sort of separate the if statement from the actual code, we use a colon here. Now hit enter on the keyboard. And here's where you want to use indentation, okay, to separate the if logic from the actual code that you want to execute, okay? So I'm going to say print. We'll print our message. Let's just say it's hot. Keep it simple. All right. So if temperature is greater than 80, print it's hot. So let's save this file and let's go ahead and run this. And I'm going to kind of, I know I'm mixing methods here, but I'm going to go back to Python and let's say weather underscore app.py and hit enter. No such file. Oh, okay, I'm not in the right directory, so that's very important. CD into conditionals. And you can sort of, a lot of times, just write the first few characters and then hit tab, and it'll auto fill it in for you, as long as it's unique enough by what you've entered, okay? So I'm going to press the up arrow a couple of times again to get back to my Python command, and I'm going to hit enter. And there we go, it's hot. So the code is recognizing that, yes, it is, in fact, the temperature is higher than 80, and so we'll print out the message accordingly. All right, now let's say we want to print this message when the temperature is higher than 80, but otherwise we want to print another message, okay? So we can sort of express the idea of otherwise, quote unquote, with something called an else statement. Okay, so hit enter again on your keyboard. Now this time it's gonna automatically indent me because it thinks I'm still wanting to write some more logic. In this case, I want to backspace back to the beginning of the line because I'm gonna go back into my if-else conditionals logic. All right, so here I can write a new condition, and all I have to do is simply type in else and then colon. Okay, so this is about as simple as it gets in terms of conditionals. I have if one condition is true, do something, otherwise do something else. Okay, so let's say, all right, let's say it's nice outside. All right, so of course, this is very coarse here, not too many options, but let's go ahead and run this. It's hot. Okay, now what I meant to do actually is change it so we could see the clause fire here. So I'm going to change that to 70 and let's execute it again. Now we're seeing it's nice outside. Okay, because the first condition basically is evaluating to false. These conditional statements evaluate to true or false inside the interpreter. So, all right, so we've got our basic, very simple weather program here. Now, let's take it a step further, and you can probably guess where we're going next. But what if we want to handle one more condition, like a sort of in-between condition, or actually the other extreme, like it's cold. Okay, so we want to check underneath a certain temperature value, and if it evaluates to true, we want to say it's cold today. Okay. So what we can do, we'll add one more statement in between the if and else, and we're going to use something called an elif statement. Now in other languages like JavaScript, this is known as else if, but it's just shortened in Python to elif. Okay, elif. So this looks more like the if statement. So now we can enter in our new condition, and let's see, what's considered cold. You can type in whatever you want here. I'm going to say underneath 50. Okay. All right, now we'll add our colon. Hit enter, and again we want to make sure we're indented in one tab, and it should automatically, I think it should auto indentate if you hit enter. So we can go ahead and do print, and let's say it's cold. There we go. All right, so go ahead and save that, and let's change the temperature just so we trigger that condition. We'll go down to 20, definitely cold, especially if you're from Florida like me. So there we go. All right, so let's change it to 60 and see if our middle statement triggers. It's nice outside. Oh, wait a minute, this is, yeah, that's correct, because now we're outside of either of these two conditions, so we're hitting the else, okay? All right, so you can kind of see the possibilities here, and again, like if-else conditionals are really at the heart of a lot of programming logic, so definitely an important concept to master. And you'll see this in just about every programming language there is, some way to implement this, okay? Now, there's another tool sort of that you can use in your toolkit to achieve some branching logic even further from this. So let's introduce a new variable. And let's see, what do we want to do here? Let's use a Boolean, is sun out, okay? And we'll say true, okay? Or let's see, how do we want to make this work? Let's say, all right, So we're saying if it's above 80, it's hot. And let's say if it's above 70 and the sun is out, it's also hot. Okay. So what kind of conditional do you think we're going to use here? We're adding a new condition amongst these existing ones. So if you said elif, you're exactly right. So now in this case, I want to test two things, right? We've only tested one thing up until this point. So here's where we can use some of our logical operators. If temp is greater than 70, and so now both of these conditions have to evaluate to true. Is sun out equals true. Oops, so we've got to spell this right with the right casing. Okay, this is case sensitive here. And now, here's one important thing to notice, and I almost made this mistake here, so I'm glad I did. When we're assigning a value to a variable, we use one equal sign. If we're checking whether something's equal to another value or not, we want to use two equal signs. Okay, very important distinction. And my IntelliSense is helping me out and reminding me that I don't have a colon hit there, so that's very helpful. All right, so in this case, we want to say it's also hot. So we'll say, okay, if it's above 70 and the sun is hot, then it's going to be hot as well. Okay, so let's say we'll change our temp to 75, and we'll say the sun is hot. So what do we predict will execute here? Should be this one, right? You know, let's change something just so we can distinguish. Let's say it's very hot, okay? There we go. All right, now let's execute this code again. It's hot. Okay, now we can tell that this one is executing. All right, so that's how we can tell, that's how we can sort of combine two different checks together. Okay, so now both of these have to evaluate to true. What if we change this to false? Now the sun's gone. It's hiding behind some clouds. So now what's going to happen? So this is going to evaluate to false since this is true and this is false. So we should not see this printed out, right? So what do you think, which statement do you think is going to print out? Let's check. It's nice outside. Yeah, so if you guessed that, you were right. So we're basically following through all of these. So we're saying, nope, it's not above 80. No, it's not above 70 and the sun is out. Okay, and it's not below 50, so else. This is sort of our catch-all, right? This executes if all else fails. So there are a couple of other things we can do. There's an OR operator. So now the difference in logic here is that only one of these has to evaluate to be true, okay? For the whole statement to evaluate to be true. So now if we run this code again, oops, I didn't save my file. There we go, very important. Save your file, let's run this again. It's hot. Okay, so now since we've changed this from AND to OR, the requirement is no longer that both of these expressions have to evaluate to true, but only one of them. Okay. All right, so far we've been using greater than or less than comparison operators, but there's another option. We can also use greater than or equal to. Okay, so let's say that this city has a record high. Okay, let's say we actually do a new if statement here. So we'll say if the temp, okay, so let's say that the record high is 99. Okay, so we want to say if the temperature is 100 or greater, then we'll print out it's a new record. Okay, so we say if the temperature is greater than or equal to 100, let's say it's a new heat record. Save that, and let's say the temp is, let's say it's 100. All right, so if this should equate to true because it is 100, and we're checking for equal or greater. Okay, so let's see what happens here. All right, it's very hot, and it is a new heat record. Okay, so of course this is a trivial example. We could have said just greater than 99, but I just want to illustrate the point here that we can use greater than or equal to, and we can also use less than or equal to. All right. How about negating a condition? So let's change this temp back to, I'll say 65. Let's add a new condition here. Let's say, what would we do if we want to say, okay, we've got something for above 70 and below 50. What if we want to explicitly say that hey, if it's between 50 and 70, it's cool. Okay. All right, so we can say if temp is greater than or equal to 50 and temp is less than or equal to 70, then, oops, I accidentally keep hitting Shift Enter, just just a habit. All right, then we want to print it's cool, right? So this is sort of a, oops, this is sort of a compound or complex condition, if you will. All right, I'm just going to do my Control 5 here. Let's see, so something went wrong here because I didn't, oh, yeah, we got it. It's cool. There we go. All right. Oh, I wanted to show a negative condition, right? Okay, so let's introduce a new variable. Let's say precipitation, and let's say this takes a string value. Let's say rainy, okay? And so let's create a new condition to sort of report on the precipitation, whether it's wet or dry. So if precip, okay, let's say if it's not equal to rain, then we're going to say it's dry outside. All right. And again, this is maybe a little contrived here, but I just want to kind of show you how to use the not equal to operator. So Python weather.py. Oh, and I don't know how, but I ended up getting into the wrong folder here. Okay. Oops. CD conditionals. There we go. It's cool, it's dry. Okay. So yep, that is just to show you how to negate a condition in your conditional statements. All right, so you can sort of start to combine these to get very complex and you'll cover a lot of different use cases in your program. All right, guys, so let's take a quick break and do our second coding challenge. All right, so here's the challenge. You're going to create a new file called greetings.py. This is going to be a greetings app, okay? And the object here is to display one of 4 different greetings based on the time of day. So we have good morning, good afternoon, good evening, and good night. And so we can get into like date objects, but that's a little bit complex for what we want to cover here. So for the purpose of this exercise, I just want us to use an integer between, well, including 0 up until 23, okay? Sort of like a 24-hour clock. So for example, 5 to 10 can represent 5 a.m. to 10 a.m., and that may be your good morning window. So it's up to you exactly how you want to divide the 24 hours, but these are the basic parameters. All right, so again, feel free to ask any questions in the comments, share your code, and look for the answer example in the repository. All right, guys, good luck, and see you in the next section. All right, guys, so now we are moving on to the next section, which is lists. Okay, so a list is one of several data structures that are available in Python. And what a list is, basically, it is a collection of items in a particular order, all stored inside one variable. Okay, so it makes sense to use a list when you have a collection of related items, and in a lot of cases you'll want to iterate or loop over that list, performing one or more operations on each item in the list. Okay, so it's a really important thing to master no matter what programming language that you're studying, because this is something that's common to all programming languages, having a sort of list or collection and being able to loop over it and perform some action for every iteration. Okay. All right, with that being said, let's take a look at the syntax. So I've created a new folder and a new file, lists.py. All right, so if I want to declare a list, and let's just think of a kind of trivial example here. Let's say this is a menu, and I want to list out all of the fruits that we have available to order, okay? So typically with lists, you'll want the variable name to be plural, you know, cars, lists, employees, something like that. Okay, so we can define a list with square brackets, and then inside these square brackets, we can literally list out each item in the list. So this is going to be a list of strings, and we'll say apple, This is a comma delineated list, so you have a comma between each item here. We'll say apple, banana, and peach. Okay. All right, so there's our list of fruits, and we can print them to the console like this, and just reference the name of the list. Save your file, and let's run that and see what we get. Okay, and so you can see the output right here, and it is literally the list, even with the square brackets included. Okay, so normally we won't, that looks a little too programmatic, right? We normally probably wouldn't want to show it in this format in our UI or in the output of our program. So we need to learn how to access items in the list. Okay, so basically lists are index-based, meaning that each item in the list is given an index or a number. Okay, and lists in Python are zero-based, meaning that the first item is not 1, but a 0. Okay, so the apple is going to be 0, the banana is going to be 1, the peach is going to be 2. So the way we can access a particular item, we can use square bracket notation and then simply enter the index inside square brackets. So say we want the first item in the list, so that'll be fruits at index 0. Okay, so save that. Let's run the program again. And there we go, we just get the first item, apple. Okay, so similarly, if we want the second item in the list, we'll actually put a 1 in here. Okay, so typically the index is going to be 1 less than what you would intuitively think. You'd intuitively think, okay, 1, 2, 3, but you got to remember, this is zero-based index, so it's actually 0, 1, 2. And this is notoriously, the root cause of a lot of errors in programming. Sometimes referred to as one-off errors, okay, where the index is off by 1 because somewhere in your program you may fail to take into account that it's zero-based. Okay, so good thing to remember, if you're debugging your code. Now we can also go in reverse order, and this is a really cool thing in Python because we don't have this in JavaScript, for example. But I have an easy way to access the last item in an array. Now, remember, this array could be really long. I mean, there could be like 1 million items. The other thing to remember about, sorry, I said arrays, stuck in JavaScript world. Lists in Python is that they are flexible and malleable, meaning we can add items to the list and delete items, which we're going to go over in a second. And so since we can't predict the length, we don't really know what the ending index is going to be if we want to access the last item in a list, which is a pretty common thing to do. So in Python, we have an easy way to do that. We can do -1, -1, okay, and that's going to go from, we're starting at 0, so -1, you can imagine we're going the opposite way from right to left in the list, and we're going to access the last item. So let's run this code again, and there we go, that gives us peach. So that's a pretty cool way. In other languages you have to do something a little bit more complex, like fruits.length -1, or something like that. Here we can just use a -1 index, so it's a very convenient tool to use. All right, so let's look at a couple of other things we can do with lists, in particular adding and removing items. Okay, that's something that you may want to do pretty frequently. So let's start with adding. So let's say we want to add grapes to this list. So I'll say fruits.append. Okay, so we can call the append function and then pass in the value of the item that we want to add. All right, so let's save that. Now let's go back to printing out our full list here, and let's just ensure that that item's been added. And there we go, apple, banana, peaches, grapes. Okay, let's add one more so that then we've got some more things to work with for deleting. Oops, didn't mean to do that. All right, so let's say pear. Okay, so now we're adding 2 things. So append will add an item to the end of the list. Now, what do we do if we want to delete an item? So we got a couple of options. So the first thing we can do is use the del statement to delete an item at a specified index. So I'm going to get rid of these append statements for now. And so what this looks like is del, that's a keyword in Python for delete. And then we reference the list name, fruits, and then we just specify the index. Let's say we want to remove the banana, so I'll say index of 1, and then print out our list. Okay. All right, so now we're down to apple and peach. Okay. So we can change this and we can delete an item at another index instead. So now let's remove the first item. and banana and peach. So this time we've removed apple. Okay. All right, so let's look at another way. So we can use the pop method, which will actually remove, by default, the last item. And the reason we'd use this is if we want to pop the item off of the list or remove this item from the list and then do something with it. So we can actually get a reference to it. So we'll say item equals fruits dot pop. Okay, so this should remove the last item, peach, and then let's just say we want to print that out. So this is the removed item. Okay, so, and I actually want to go back into the correct folder here. All right, let's execute that code. So peach, now we've got a reference to that last item that we've popped off the list. So another thing we can do, we can pop, so by default we pop off the last item in the list, but we can also specify an index. So say we want to pop banana off the list. So I'll save that, and this time let's run the code again. This time we get banana. Okay, so this is a really useful method if we want to actually remove something from the list and then retain a reference to it to do something with it. Okay. All right, finally, let's say we want to remove an item by the name or by the value of the item in the list. Okay, so in that case, we can use the remove method. So I'll change pop to remove. All right, and we'll get rid of this reference for now. And we'll change this back to fruits just to see the result. Let's say we know the value of the thing that we want to get rid of. So let's say, I know there's an apple in there, so I want to get rid of that. Okay, and let's run that code. And there we go. So we've removed that explicitly by the value. Now we talked about adding an item to the list using the append method, which adds the item to the end of the list. But what if we want to add an item somewhere at the beginning or somewhere in the middle of the list? Well, to do that, we can use the insert function. Okay, so I can do fruits.insert, and this function takes two arguments, which is an index and the value to be inserted. So let's say I just wanted to add something to the very beginning of this list. So I'll say 0 index and grapes. All right, and let's verify that. We'll run the code, and there we go. So now we have a new entry at the beginning of the list. Okay, and similarly, I could add this anywhere I want. I could add this to the second position. Remember, that's on a 0-based list, that would be 1. Okay, so let's run that code, and there we go. So now it's in the second position. So insert, we can pass in the index and the value to add a new entry anywhere we want in the list. All right, let's look at another couple of things that we can do with lists that are pretty useful. Say we just want to know the length of the list. Okay, so in that case, I can call the len method, which obviously is short for length, and the reference to the list. Save that and run it. And so this will give us the length of the list, which you can see there are 3 items. So that gives us 3 length of the list. We can also do some other cool things. We can sort lists. Okay, so let's go back to fruits. And let's add another few items in here. Let's say grapes. Let's say watermelon. Okay, just so that we have some things out of order here, because I'm going to show you how to sort a list, which is really easy. In fact, I'm going to, so we can call fruits.sort, okay? And what this does is, depending on the nature of the items in the list, this is a string list, so it's going to sort it in alphabetical order from A to Z. All right, if this was a numerical list, it would sort it from lowest to highest. And this is a permanent change, so it's permanently changing our fruits list. So let's run that code. And see, we get the apple, banana, grapes, peach, watermelon. Okay. Let's create a new numerical list just to see how that looks. So I don't know, I'll just say prices. All right, let's say 101, 23, 7. I'm just making up random numbers here. 67, 1, 2003, something like that. prices sort, and let's print out prices. Save the file and let's run that code. So there are our prices, nice and sorted from lowest to highest. Now we can also print out our fruits array or any of these in reverse order. So let's look at how we do that. Well, let's just do it on the prices since we're currently using that. We have a reverse function that we can call. So this will give us 2003, 1, 67, etc. in that order. Let's run the code. And there we go. So a lot of cool built-in functions that we can use to manipulate our lists. As you could imagine, this could be useful for sorting, like when you have a sort of a sorted table in a UI or something like that. All right, so another concept I want to talk about is the concept of slices. So I'm going to go back to our initial fruits array, or sorry, a list. I keep on calling it array because I'm so used to working with JavaScript. All right. Now let's say that we want to only work with a sub portion of our fruits array. So there's the concept of slices, where we can specify a subsection of fruits that we want to work with. Okay, so let's say I just want to work with the first 3 items. All right, so I can say, I'll tell you what, let me just do this right in the print function so that we can see this. Fruits, and now I can use my square bracket notation, and I can specify a range of items I want to work with. So 0, that'll be the first item, and up until, but not including, the 3 index. Okay, so that should give me grapes, watermelon, and apple. So let's run that code. And there we go, our first 3 items. Now, one shorthand kind of tip here, you can actually omit the starting position, and that will by default start from the beginning of the list. So I can just say :3, and that'll give me the first 3 items. Just the same as it did before, okay? Conversely, we can specify any range. So let's say I want to, what would you type in if you wanted to reference watermelon and apple? Now remember, the ending index is non-inclusive, so I want to specify one more than the one I actually want. So 1:3, and that'll give us watermelon and apple. Same thing for the end of the list. If we, let's see, if we say 1: and then leave off the last index, that'll go all the way to the end by default. Okay, so that should give us watermelon through the end of the slice. I should say slice. Oh, I didn't save the file. Okay, let's try that again. And there we go. So we get watermelon through the end of the list. Clean this up a little bit. All right, so another really useful use case of slices is if I want to copy a list. So let's say I have my initial list of fruits, and let's say I want to create a new list of fruits, and I want to start with this initial by copying this initial fruits list, and then maybe I'll add some more or whatever I want to do. But this slice syntax gives me a very convenient way to copy lists. And so the syntax goes like this: only the colon. So you omit the beginning and you omit the ending index, and that just gives you the whole list. So let's just print this out to the console, and hopefully this new list will contain an exact copy of our beginning fruits list. Okay. And there we go. So now the contents of fruits has been copied into our new list, new fruits. So a little bit earlier I mentioned that you'll often want to loop or iterate through a list of items, performing an operation for each time through the loop. This is a really common thing to do in programming, so let's take a look at how we can do this in Python. All right, let's start with a new list here. I'm going to say cars. So let's say this is an app for a auto dealership, and we want to list out the different cars that they have available for sale. So we'll say Toyota, Honda, Lexus, oops, let's say BMW, and one more, let's say Subaru. There we go. All right, so let's say, for example, that we want to loop through this list of cars and output a message for each car, okay? So for that, we can use a for loop in Python, and the syntax is very simple. For x in list is basically the formula. So for x in, and then the list is cars, okay, colon. And so x is going to refer to each item as we're going through the loop. So instead of x, I'm going to change this to car. So for car in cars, okay? And I'll hit enter there. And here we got to remember to indent 4 spaces. And this is where we actually write the code that we want to execute for each iteration through the loop. So I'm just going to print a message here, and let's say come out and let's say come check out our, and then we'll say name of car. Okay, so car, and again this is referencing this right here to reference each item in the list, and I got to make sure to use a F string here. Okay, and that's it. That is the basic kind of hello world example of a simple loop. So let's save that code and let's go ahead and run it. And there we go. Come check out our Toyota, etc. for each car in our sort of inventory. Okay, so we can put as much or as little code as we want in each loop. Now, if there's something we want to do after all of the iterations are complete, then the only thing we need to do is kind of come down here and then unindent. Okay, so now we're outside of the for loop. All right, so we can maybe print another message and say, thanks for stopping by. Okay, so in other words, we should see this print statement execute for each item in the loop, and then this final one, since we're outside of the indentation, should only execute once. So let's check that. There we go. Thanks for stopping by. All right, so if you notice all of these are lowercase, so do you remember which method we can call on a string to uppercase the first letter? All right, if you guessed title, you are correct. So let's save that and see if that looks any better. There we go. All right, very good. So is there a way to break out of a for loop or to short circuit a for loop? Thankfully, yes, there is. So we could do something like, let's say if we, once we hit Lexus, we want to stop the loop and not execute any further statements. So we can use a if statement in here. If car equals Lexus. Okay, and now we pay attention here. We have another indentation, very important. Break. Okay, and that's a keyword basically that tells the interpreter to break out of that for loop. Okay, so we should only expect to see the first 3 items, because we're actually going to print Lexus and then we detect that it's Lexus and we short circuit the loop at that point. So I think we'll get the first 3 items if I did this correctly. So let's try. There we go. Toyota, Honda, Lexus. So we've short-circuited out of the first 3 loops. Now there's another way to achieve this without the break. Now let's say, what construct have we learned that you think we might be able to use here to just iterate through a subset of the list? That's right, a slice. So in order to iterate, let's say, through the first 3, we do colon and 3, like that. Okay, so remember we haven't specified the beginning index, so it'll default to 0, and the 3 is not inclusive, so we should get 0, 1, 2 through Lexus, kind of the same output that we had before. So let's try that, and there we go. So there's another way you can use slices to iterate through a smaller portion or a subset of an initial list. All right, so now let's say we want to add some more information into the mix here, and let's say in addition to the different types of cars, we also have each one available in different colors, okay? So let's create a second list with the colors. So we'll say white, black, and let's say red, all right? So now, let's say that we want to output a message not only for each car, for each type of car, but for each color combination as well. So how can we achieve that with loops? All right, and I'm going to get rid of our slice notation here. So we're just back to looping through the initial cars list. And so if we want to add we have two different lists here, and we want to output a message based on the combination or the relationship between both of these. So what we can do is we can have something called a nested loop. Okay, so we can have our outer loop looping through each of the cars, and for each iteration of that outer loop, then we're going to subsequently iterate through each iteration of the color list as well, okay, and print out a message for each one. So I can come down here and indent again, and we'll do another for loop inside of colors. So I'll say for color in colors, colon, indent again, and I'll add back our message, but this time I'm going to add the color. So we'll say check out our black Toyota or whatever it is. So let's say color. There we go. All right, let's see if this works. So a loop inside a loop, otherwise known as a nested loop. And there we go. So now we've got a combination, a message for every combination of colors and cars together. All right, now let's say you want to have some code execute in a loop-like fashion, but you don't have a list or any kind of collection to use. You just want to do it X number of times. So luckily there's a way to do that as well. I'll get rid of this right here. Well, I'll get rid of this loop. And so we can use the range function to specify an arbitrary number that we want to loop over. So I can say for X in range, let's say I want to do 5 times. Okay. Print X. Okay, so since we don't have a collection to loop over, what do you think the X is going to refer to here? Let's run the code and see. There we go. So we have just like an index or a number indexed from 0, a count of numbers starting from 0, since we've specified 5. Now we can also specify a range from to, like say 1 to 5. So what do you think the output of this code will be? We'll save it and run it. 1, 2, 3, 4. Okay, so it's starting from the first number and non-inclusive to the second number. So we've got 1, 2, 3, 4 up until but not including 5. So this is useful if you just want some code to execute n number of times. You don't necessarily have a list or any kind of collection to work with. All right, so another type of loop, another useful looping construct is something called the while loop. Okay, so the while loop, basically how it works is it executes some code while a certain condition is true. Okay, and I'll show you how this works here. So we'll start with an outside variable. We'll say I equals 10. So we want to execute some code, let's say while I is less than 20. So you might recognize that this looks very much like an if statement where we're testing a certain condition. Okay, let's say print I. And now we're going to, with each iteration of the loop, we're going to increment the I variable. Okay, so now here's a situation where we want to say I equals I plus 1. And if you recall, we had some special syntax to do that. Okay, so we're incrementing I basically with each iteration of the loop. And so this loop should execute until I equals 20, all right, right up until it's equal to 19. And let's run this code again. And there we go. So this code is executing while this condition is true. And once I goes beyond 19 up until 20, then the condition is no longer true. The code stops executing. So this is another good trick to have in your tool bag. The while loop definitely comes in handy a lot of times. All right, guys, so let's take a break here and take a look at our third coding challenge. All right, so this is the soda fountain coding challenge. We're writing a program for a soda fountain, and the requirements are right here. Create a list of at least 4 soft drinks. So for example, Coke, Diet Coke, Pepsi, Sprite. Create a list of at least 4 sizes, okay, sizes that the drink is available in. And what you ultimately want to do is have the program output a textual button label for each combination of drink and size. So, for example, press here for a large Coke. So some additional requirements: make sure the soda name is capitalized, and sort the sodas alphabetically A to Z. All right? So, as always, any questions, feel free to enter them into the comments, and the answer key will be available in the repo. All right, guys, good luck and see you in the next lesson. All right, guys, welcome to the next section of the tutorial, and we are going to continue our talk about data structures and kind of go over the 3 remaining ones that we haven't covered so far. Okay, so the next data structure we're going to talk about is called a tuple. Okay, now a tuple is very similar to a list. There's one major difference, and that is that tuples are a fixed collection of items assigned to one variable. In contrast, lists can expand, can shrink, we can add and remove items, and they're really malleable. So a tuple is when you have a collection of items that are going to be fixed throughout the duration of the program. Okay, so let's look at how to define a tuple. Let's say that this is a program for a pizza shop and we've got a fixed number of toppings. It's not going to change, and so we decide to use a tuple to contain that collection of toppings. So I'm going to say toppings equals, now with a tuple we use curly braces or parentheses, and we have a list delimited group of items inside it. Okay, so I can say pepperoni, if I spelled that right. All right, and again we separate each item with a comma. Mushrooms, and let's say olives. All right. And so aside from the fact that this is a fixed collection and we can't really append anything or pop anything or add or remove anything, other than that it behaves very much like a list. So let's see what we can do with this here. Let's just print out the whole thing for starters. Okay, save the file. Let's run this code. All right, and as we can see, exact same behavior as we had with the list. It literally prints out the entire thing, including the parentheses. Okay, so again, like a list, we can access a certain item by its index. So this should give us the first item in the tuple, pepperoni. There we go. And again, we can loop over these using the same for loop syntax that we did with a list. So let's say for topping in toppings, print topping. All right, save that and let's run that code. And there we go. There's our output of the, oh, and I'm printing that first one twice, but you can see that it's looping through and printing out each item one by one. All right, so, one other thing I want to mention about tuples is that, it may not always make sense, but sometimes you might find that you have a tuple with one item, and in that case, you still want to end it with a comma, even though that looks kind of funny, because a comma is sort of one of the ways that the interpreter knows or identifies this as a tuple. So if you did that, that wouldn't work. All right, so you've got to have a comma, even if there's just one item. So let's run this code. Yeah, and so it's printing it out one time for my standalone print statement and one time for my loop. All right, so this is pretty simple stuff here. We're going to move on to the next data structure, but yeah, this is the high-level overview of tuples. All right, guys, so the next data type we're going to talk about, or the next data structure, is a dictionary. So if you come from the JavaScript world, you might know a dictionary as an object. Okay, it looks very similar. Those of you who aren't coming from the JavaScript world, a dictionary, it's basically a key value collection of properties. So let me show you through example. I'm going to create a dictionary for an employee, all right? So I'll say employee equals, and we use curly brackets, okay? And then inside the curly brackets, we'll just have a list, or basically a list of key value pairs. So for example, we might have name, okay? And these are separated by a colon. The key value pairs, they can be single quoted or double quoted. And each key value pair, again, name being the key, Bob being the value, each one is separated by a comma, okay? So let's say DOB for date of birth, and let's say 2/3/1965. And the other thing to note about dictionaries is, well, a couple of things. First of all, like lists, they're dynamic, so we can add and remove properties at any time. And also the values can be different values. So we can have strings, we can have numbers, and we can even have other lists. For example, if we want to have a list inside of this dictionary of Bob's skills, we can do something like this. So let's say HTML, CSS, and JavaScript. All right, so there is our dictionary. And like other data types, we can print it, employee. So let's save that file and let's go ahead and run this. So I'm going to say Python dictionaries.py. And there we go. So we get a very literal string representation of our dictionary. Okay. Now, next thing to find out is how do we access the various properties of our employee dictionary? So we can do that with the square bracket notation. So I've got employee, and I can reference the various properties by the key. Okay, so I'll say employee, square brackets, and then let's say name. Okay, let's run this again, and we get Bob. All right. Similarly, we can go through and access any of these properties within here. All right, so I mentioned that dictionaries are dynamic. So let's see how we can add a new property to the employee dictionary. So I'll say employee, and we use the same square bracket notation, and we can just add our new property. So let's add a Boolean property, and let's say is manager. Okay, and we can set this to, now remember with Booleans, they've got to be capitalized, so I'll say true. I'll save that, and then I'll go ahead and reference that in our print statement here. So this should give us a true or false. Let's run this code. There we go, true. All right, so that is how we can add properties. All right, now let's look at how to delete them. So if you remembered with the list data structure, we could use the del statement to delete certain items in the list. We can use that same sort of syntax to delete something from the employee dictionary. Okay, so I'll say del employee, and then I'll reference it by, let's delete the date of birth. All right, so now when we print out an employee below, we should have everything except the date of birth. Let's run that code. And there we go. So we've deleted that item from the employee dictionary. All right, so let's see what happens when we attempt to access a property that doesn't exist. All right, so I'm going to say employee, and let's just think of a property here. I don't know, last name. So we haven't set last name, so let's see how this behaves when we try to access this property. Run that code, and it looks like we get an error basically saying that this property doesn't exist. All right, so to mitigate this, we have an alternative method that we can use to access properties that is a bit more safe, and this is the get method. So we can use the get method to look for a certain property, and if that property doesn't exist, we can actually set a default string that'll be returned in place of an error. So let's try that. So I'm going to do employee.get, okay, with parentheses instead of square brackets. And the first argument is going to be the property I'm looking for, and the second argument is going to be my custom error string, basically, or just string that I'm returning. So I'll say this property doesn't exist. So let's save that, and now let's see what we get when we run this code. Oh, well, it looks like I've got a syntax error beside. That complicates things. All right. All right, now I've got valid code, so let's clear this out and let's run that again. There we go. So now we get a clean sort of exit from this, this code. We're not getting that ugly error message anymore. We've got a safe way now to attempt to access a property that may or may not exist. Maybe we don't know. All right, next let's look at how to loop over dictionary objects. All right, so to loop over the items in our dictionary, we can use the for loop just like we did with lists. So let's take a look and see how that works. All right, so I'm going to say for, which is a little bit of a difference in syntax here. This time I'm going to say, instead of, car, in our cars list, we're going to say for key value in our dictionary, since a dictionary consists of key value pairs. So I'm going to say for key value in employee.items, and this is just sort of a special syntax here that we use. All right, colon. All right, and now we can go ahead and write our code that we want to execute for every iteration of the loop. So I'm just going to print out the key value, the keys and the values. So let's say print, I'll do a formatted string, and I'll say key key, and then we'll say value and output the value. Yeah, that looks right to me. Let's go ahead and save that and let's run that code. And there we go. We get a nice outputting of the keys and the values for each pair in our employee dictionary. All right, so to round out our discussion of data structures, I want to go over the final one, which is a set. Okay, and this is probably the data structure that I use the least amount. I use lists and dictionaries far more often, but I just want to briefly cover it just so we touch on all of them at least. So the main difference, a set is very similar to a list. The big difference here is that sets are unordered, unchangeable, and do not allow duplicate values. So really a set is sort of the strictest of all of the data structures available. Let's see how this works, and we'll go back to our fruits metaphor. So we'll create a set of fruits. Now these, I guess the main reason why I'm using a set here is because I don't want these items duplicated, right? We only want to mention it once on the menu, for example, if this is for a restaurant. So with sets, we can use curly braces, and I'm going to say apple. Another thing about a set is the order is not guaranteed. Like you can sort lists and sort of order them. You can't really do that with sets. So let's say grapes, peach, what did we say? Banana. Oops. Okay. So just want to, why do I keep doing that? There we go. Clear that out. And let's just run this code. Oh. Let me save my file. That would help. Like, why isn't it printing anything? There we go. So this is the same pattern we've seen with all the other data structures. It literally prints it out as is. And I'm not really going to go into too much detail other to say that all the other behavior is very similar to what you find with a list. Let's iterate over these so we can use for fruit in fruits just like we would with a list. And let's print fruit. Everything else is the same, the way you access it, the way you loop over it. It's really just the behavior, the set of rules that's different for sets. So there we go, peach, apple, peach, banana, apple, grapes. And notice that the order is not intact from what I set. So if you really need the order to if you need your code to maintain, you need your data to maintain a certain specific order, then a set is probably not the best choice here. All right, so that concludes our short talk about sets, and that concludes our overall talk about data structures. The next thing I want to touch on is functions, and then we're going to start working on our final project. All right, guys, see you in the next lesson. All right, guys, so in this section, I want to talk about functions. Now, functions in Python and other languages are blocks of code that work together to perform a certain task or calculate a certain value. They often have inputs, or function parameters, and outputs, which are known as return values. Okay, so let's look and see how to define a function in Python. Okay, so this first part is known as the function definition. And the first thing I'm doing here is I'm inserting the keyword def. Okay, this lets Python know that I'm about to define a function, followed by the function name, followed by an empty set of parentheses, and this is where our function parameters will go if we need any. If we don't have any function parameters, then we can leave it empty like this, and followed by a colon, which I think probably looks familiar to you guys by now. All right, and so here is the body of the function on line 2, where we can sort of write the code that we want to execute in this function. So I'm just going to print a greeting. Let's just do a hello world. Okay. And so that is the function. Now what I need to do is invoke the function or call the function, okay, so that it actually gets executed. If I just run this code as it is, nothing's going to happen. All right, we actually need to call the function. So see nothing, we get nothing there. And so how to call a function? We basically reference the name, greet_user, and end it with a set of parentheses. So let's save that and let's run this file again. And we get hello world. So that's your basic hello world function. And if you remember back to the first lesson, we were just simply printing hello world. Well, now we have it wrapped in a function. So why use functions? Well, there's lots of reasons, really. It's just a good way to organize your code, basically. It's a lot easier if you have sort of your functionality grouped under logical names, semantic names, so you can clearly see what's happening in a file, especially if you got a file that's potentially tens of thousands of lines long. Functions are also good for being able to import and export them from various files, which we'll see in a few minutes here. But anyway, this is the basic syntax for functions. So let's change this up a bit and let's actually pass in a username. Okay, so the first thing we want to do is define a parameter. So let's say, whoops, I don't know why that jumped down there like that. So we go here in the parentheses, if I could spell right and talk at the same time. There we go, so we got name. So remember, this is called our function parameter. And when we actually pass the data from calling the function, then it's called an argument. So I'm going to say Jonathan, and so we can change our print statement down here to output the name instead of hello world. So I'll say hello name. And so this name is referring to this function parameter, which is coming from the argument here when we invoke the greetUser function. So let's go ahead and save and run this file, and we get hello Jonathan. All right, great, so far so good. Now, let's say we want to do a first name and last name. So how do we do that? So we'll have to have two parameters and two arguments. So we can separate these by a comma. Now, an important thing to remember is that the order matters. Okay, so you could call these anything you want. I could call this XYZ ABC, and basically the Python interpreter will know just by the order that these things are passed in by. So I'll show you what I mean. Let's update our message first. So I'm going to say first name, and then I'm going to say last name. Okay, and finally we have to update our function invocation to pass 2 bits of data now instead of 1. So we'll do, oops, my last name. All right, let's save that file and run it again. And there we go. Hello, Jonathan Spruance. All right, so we kind of see how the basic usage of a function is, how to pass in arguments to our function parameters, and then how to use them within the function body. All right, so these are our inputs, by the way, but this function really doesn't have an output. I mean, technically it's printing a string to the console, so that could be kind of thought of as the output, but in other cases we could actually have a function that returns a value, which we could then set to a variable. So let's do that real quick. Just do a quick example. So this is sort of a classic example here. So I'm going to say number 1 and number 2. Okay, so these are going to take integer or float values. And I'll return number 1 and number 2. Okay, and so we can now call this function. Let's see, add numbers. Let's say 2 and 3, okay. And so really this is, I don't think we're going to see anything if we just run this code, except for the greeting thing that I didn't delete, but let's just run this. Yeah, so we get that first greeting, but we're not getting anything from here. So in order to actually display this, this sum, we need our function to return a value to a variable and then use that. So what we can do, we can create a new variable called sum and then assign that to the return value of the function. And here's how you do that. So this function is going to return a value right here on line 7, and that'll be assigned to this variable. Okay. So then after that we can try to print out the result. There we go. So let's save that and run this file again. And there we go. So now sum contains the result of the function, the result of the calculation as the return value. All right, so if you recall, I mentioned that the order is important, that the order matters in terms of your function parameters. And so there is a way, though, that you can make it a little more flexible or sort of safeguard against passing things in the wrong order. So I'm going to just comment out our sum example for now. So we've got first name and we got last name. And so when I invoke greet user, I've got to remember that order, right? However, there is an approach, and it's called keyword arguments, where I can sort of label these arguments and then not worry or sort of be freed from the need to recall the exact order. And I'll show you what I mean here. So I can actually label my arguments. I can say, let's say I wanted to do it in the opposite order. So last name, okay, and I type in my last name, and then, whoops, and then first name. Okay, so now that I've got these labeled, the order no longer matters because the interpreter is able to say, hey, this is labeled first name, so obviously this, we're going to match this up with the first parameter here and vice versa. Okay, so let's save this code and let's just verify that we still get the same hello message. Yep, there we go. So even though that I've reversed the order, that's okay now since I've added these what are they called? Keyword arguments. Right. All right, so let's add one more parameter. Let's say age, okay? And let's say, well, let's change the message so we say Jonathan Spruance is, and then output the age here, okay? All right, now I'm not passing in an age here, so what do you think is going to happen? Let's save this code and we'll rerun it and see what happens here. All right, so we're getting an error because we're missing one argument. So it's saying, hey, you've got age here defined in the function parameters and the function definition, but you're not passing in an age here. So what's the deal? So there's a couple of things we can do. First of all, I can add an age here. I can pass it in, right? I can say 99. Yeah. Oh, what's it saying here? Cannot appear after keyword arguments. Okay. You know what? Let's go back to our... Let's get rid of these keyword arguments and just... Because now the order matters and I'm not labeling it, so that's why it's complaining. But I don't really want to use the keyword arguments anymore. So, okay. Yeah, let's save that now. Let's see if the error message goes away. It should, right? Yep, because now we're passing in all of the arguments. So what if we kind of wanted to safeguard against this because we don't know, necessarily if the person's going to send in the age or not? So we can use something called a default value. So this is basically saying, okay, if no value is sent in for this corresponding parameter, then go ahead and use this default of 99. All right, and let me change it just so that we can tell that it's different from the last run. There we go. So I'm going to save that and rerun it, and let's see what the behavior is. Yeah, Jonathan Spruance is 90. So, yeah, so despite the fact that I'm not passing it in, it's able to use this default, thus we don't get an error message. So these are just some really cool tools that provide a little more flexibility around your function invocations. Okay, and one more thing I just wanted to add to this while we're on sort of our default values is I can also choose to have a blank default value just like this. If I want the function to run, if I don't want it to return an error message, but the person may not be passing in the age or this particular parameter, but I don't want to necessarily provide a specific default value, so I can just do some empty quotes here, and this will still run, okay, although it won't give us any age. So let's see what this looks like. Yeah, so you get nothing basically here, but at the same time we don't get an error message, so that's sort of a way to make the parameter optional. All right, so I mentioned earlier that one of the benefits of using functions is sort of separation of concerns and the ability to organize your code. All right, so we've organized our code into different functions here. We've got two functions, greet user and add numbers. And so we can take this a step further and we can actually create what's called a module. So a module is it's basically just another Python file that you can import into your current working file and then access all the functions within that file. Okay, so I'll tell you what, let's go back to our Hello World example. So we've just got a basic introduction here, and let's go ahead and create a new module that we can import into this file and then use its functions, okay? So I'm sort of going to mirror some of the code that we just did. I'm going to create a new file under Hello World, and I'm going to say greetings. I'll say greetings.py, okay? And so, well, I won't copy and paste the code. I'll just create a new function here. So I'm going to say greet user, and let's just make a simple version of it with the name. Okay, and then we'll say print. Well, we'll say hello. So we'll do a formatted string, hello name. Oh, and I got to end our string. There we go. All right, so control save. Now we've got a function here, and we don't need to do anything to explicitly export it, okay? Because we're going to reference the import, or sorry, the import is going to reference the file name. Okay, so that's the kind of connection between the two. I'll show you what I mean. So if we go back to hello world, and all I have to do is at the top of the file use an import statement, the import keyword, and then just use the name of the file. Okay, so greetings. All right. So now in my hello world file, I have access. So this greetings becomes sort of a namespace. Okay, and the interpreter knows. Okay, go out there and find the greetings.py file, and then sort of create this object, which I can then access the functions of that object using the dot notation. So let's say here I can do, greetings dot, and what's our function? Greet user, and we can see it right here in IntelliSense. Okay, so I'll provide my name, and that is all there is to it. So I can save that and run this file. Now notice that I'm running the hello world file this time, rather than the greetings file. So we'll do hello underscore world.py. Oh, and there's something wrong here. Let's see, what have I done wrong? Oh, I'm in the wrong folder again. I guess I'm switching around too much. So let me back out of that. CD into hello world. There we go. Okay, let's try that again. Python hello world. And there we go. Hello world, hello Jonathan. So we can see that the sort of glue between these two files is working. We're importing the greetings module and able to access all the functions. So you can kind of see the power of this just as a organizational tool. You know, I may have tons of functions in here that are all sort of related, like maybe they're all related to registering a new user on the website. And so I've got all my registration functions in here, or maybe just all my login functions. And that way I can have my own dedicated sort of login module. And then it's easy for me to know, you know, where I'm going to go to find, where I need to go to find the login related logic in my program. And of course, the bigger the program is, the more helpful that really becomes. All right, so that is modules, and I think that's all I wanted to say about functions for now. So that gives us a good overview. And that concludes sort of the lecture part of this lesson, or this tutorial. So we've covered a lot of different things. We've covered variables, data types, we've covered logical operators, comparison operators, we've covered lists, a bunch of different data structures, tuples, dictionaries, sets, and we finally covered functions. Okay, so that should be a pretty good overview of the basics of Python. From here, where I would go next is maybe kind of learn a bit about object-oriented Python, so sort of dive into classes and how to create object-oriented structures within your programs. But we'll leave that for the next tutorial, the next video. For now, what I want to do is pivot to our final project. Okay, so we'll take a quick break, and I'll meet you in the next video, and we will start our final project together. All right, guys, so it's time to start on our final project, which is going to be a command line interface number guessing game. So here's how it works. The program will generate a number from 1 to 0, a random number, and the user will input their guess. The program will then tell them whether the guess is too low or too high until they guess it correctly, and the game ends. Then we'll enforce a max upper limit of 6 on the number of guesses that the user can take, so they'll have to guess the number in 6 guesses or less in order to win the game. This project will cover a lot of the topics we've learned so far in this tutorial, so we'll break the problem down into a series of smaller steps and iterate on them until the program is complete. So I'll kind of lay out each objective step by step, and if you like, you can pause the video and try to finish the coding for that step by yourself, or you can simply follow along. All right, so with that said, let's get started on step number 1. So first of all, I've created a new folder called Guessing Game, and I've created a new file inside that folder, guessing_game.py. So if you go ahead and complete that setup, and then we'll get started with the first step. All right, so the first objective is to get the guess from the user and reflect it back. So at this point, I encourage you to pause the video and see if you can give this a try on your own. Otherwise, feel free just to follow along. All right, so if you remember from earlier in the tutorial, we said that we can use the special input function to gather input from the user on the command line. So I'm going to output a message here. I'm going to say, "Welcome to the guessing game. Please enter your guess." There we go. Now, in order to use this input, we've got to set it to a variable. So I'm going to create a new variable called guess and set that to the return value of this input. Okay. Then after that, we can simply use the guess variable. And I'll just print out a statement for now saying what the guess was, just reflecting that back to the user. So I'll say you guessed, and then the number that they guessed. All right, so let's save that and let's run that. All right, so far so good. So I'm going to guess 5. You guessed 5. All right, so far so good. So we're ready to move on to step number 2. All right, so for step 2, we are going to generate a secret random number and then compare that secret number to the guess. So we can start to put together the logic saying, you know, your guess is too high, your guess is too low, or you've guessed the number. Okay. All right, so the first item to generate the secret random number, we are going to import a special module that's available called random. So I'm going to use the import statement and say import random. Okay. Then I'm going to create a new variable for the secret number. So we'll call it secret underscore number. Now we can use our imported random module like this, random, and we can call a method called randint. Okay, and that's going to take 2 arguments, the lower bounds of the random number and the upper bounds. So I'm going to say 1 and 100, so that this should generate a random number between 1 and 100, but inclusive of both 1 and 100. Okay, so now we've got a random number in our program that we can use to compare to the guess. So how do we compare the random number to the guess? If you want to pause the video at this point and try to set up the logic for the too high, too low, or you've guessed correctly, you can go ahead and do that. Otherwise, we will proceed, and we're going to use some if-else logic here. Okay, so first we'll say if guess is higher than the secret number, then what do we want to do in that case? So we'll do a colon, and don't forget to indent on the next line. And let's just print out a statement here. And we'll use a f string. Or no, we don't need an f string because we're not using a variable here. So we'll say your guess is too high, right? Okay. And so we'll do the same thing for the guess is too low. So we'll say if guess is less than the secret number, then we'll say your guess is too low. Okay, great. So finally, the other condition is if the guess is correct, and so we can just use an else statement here. Okay, and this time we will use an f string because we'll kind of reflect back what the secret number was. So we'll say you guessed the secret number, and then we'll output what the secret number is. And we'll say you win. All right. Does that look correct? I've closed my quotes and everything. All right, great. Okay, so let's save the file and let's test this code and see if our program works so far with what we've got here. So I'm going to run the code again. All right, this time I'm going to guess 50. Oh, and looks like we've got a, okay, so we've got a type error. Greater than is not supported between instances of string and int. So do you remember how we solved this problem in the past? I've got a typo here as well. So again, we're trying to compare 2 different data types, which is not going to work. So do you remember the data type that the guess is going to be? Since the user has entered it on the command line, input always returns a string, right? So What we could do is we could cast the string to an integer, like this. But if we do it here in the if-else logic, oh, I found another mistake, so this should be elif, right? If, elif, else. Okay. So if we do it here, then we're going to have to repeat that logic and do it on line 15 as well. So instead, we can actually just go ahead and do the conversion immediately up here where we have our input statement. So we can wrap this entire thing in a cast to int. Okay, so that way guess, the guess variable at this point is always going to be an integer. So let's save the file and let's try to run this again. See if we get a better result. So I'm going to say 50. You guessed 50, your guess is too low. Okay, perfect. So that means the random number is above 50 and all of our logic is working up to this point. All right, so we're on to step number 3, which is make the guessing logic repeat until the game is over. So if you noticed on the last run, I was able to input a guess and then we got our feedback, but that's it. The program stopped running at that point. So we need some sort of construct to make this guessing logic repeat until the game is over, okay? Now there are a couple of different ways that we could go about doing this, and I think we're going to try one way and then we're going to iterate on that on the next step and improve it a bit, okay? So if you guessed that we could use some sort of loop to make this logic repeat, then that was a really good guess. That's exactly what we're going to do. And there are a couple of different kind of loops. And so if you recall, we talked about a while loop, and a while loop repeats some logic or loops over some logic while a certain condition is true. So what if we set up a variable that captured whether the user has won the game or not, and then repeat this logic while that variable is false until we set it to true once they've guessed the correct number. So I'm going to introduce a new variable called oneGame, and I'm going to initialize that variable to false. Okay. Now we can use this as the target of our while loop. So we can say while oneGame is not true, okay, execute the guessing logic. Now I need to take all of this guessing logic here and indent it, right? Because now it's inside the while loop. And so now we need a way to set this variable to true once the user has guessed the correct number. So this looks like a good place to do that. We have an else clause here, and this is where the user has correctly guessed the number oneGame. So we'll set this to true right here in this clause. Now we need some sort of cue that the game is over, so I'll go outside of the while loop and we'll just print a new message and we'll say thanks for playing. That way we can tell that at this point we're outside of the while loop and the game is over. Okay. Now this code I think will probably work. There's one thing that sort of bothers me here, and that is, we're using if the guess is too high, else if the guess is too low, and we're saying else in all other cases. We'll assume that the user has won the game. So while that should hold true because the guess can either be too low or too high, so at all other conditions that means the user has correctly guessed, I just would feel a little bit better if we were a little more explicit and only execute this clause if we truly match the guess with the winning number. So that being said, there's nothing wrong with just using if statements here. Okay, so I'll say if guess is higher than secret number, if guess is lower than secret number, and instead of assuming that all other conditions would result in a win, I just want to explicitly sort of compare here the guess with the secret number. So I'll say if guess is equal to, and that's a strong equals as opposed to an assignment operator, if guess is equal to secret number. So we're explicitly making sure that this evaluates to true. Then at that point the user has won the game. And I'll just fix this typo here. Okay, that looks good, so let's go ahead and save the file and run this code and see if our looping logic is working. Alright, so I'll start with 50. That seems like a reasonable first guess right in the middle. I guess it's too high, so my strategy is going to be to take 50% of that initial range, and so that's too high, so we'll go down to 12. That's too high. 6? Still too high. Wow. And I finally guessed the number 3. Okay, so this is looking good so far. You've guessed a secret number 3. You win. Thanks for playing. So at this point, we've got a pretty well functioning game. So let's go on to step 4 and see what the next requirement is going to be. All right, let's take a look at step number 4. Limit max guesses to 6. Okay, so as the game is right now, basically the user can guess an infinite number of times until they guess a number. That's no fun. We want to say, okay, you've got 6 guesses to get this thing right, or else you lose the game. So, how would we implement that? Well, I think we need a global variable to hold the max number of attempts that we're going to allow the user. So, I'll come down here and I'll create that new variable. I'll say max attempts equals 6. All right. Now, there's a couple of ways we could go about implementing this. We could keep our while loop and just simply increment, track the number of attempts that have happened so far and sort of increment them with each iteration through the loop. But I think there's a cleaner way of doing it where we can probably end up using less code. And that is to use a for loop to actually iterate over the number of max attempts. Okay, that way we can get rid of our one game flag and we don't have to keep track of the attempts because the loop is inherently keeping track of that for us. So let's give that a try. So I'm going to start by removing the one game variable. Less code is always good because, there are less things that can go wrong and less things to keep track of. So we'll change our while loop to a for loop. So if you recall, the syntax for that is for attempts in. Now remember, we're not iterating over a collection here. We're simply iterating over a number or a fixed number of times. So we can use the range keyword, and the range accepts the actual number of iterations. So in this case, we're capturing that in our variable max attempts. So our for loop is going to look like this for attempts in range max attempts. So this thing is going to loop 6 times, no more, no less. However, if they guess the right number before 6 tries, then we want to short circuit this loop. Okay, we want to stop it early. So I'm going to remove this print statement for now. And do you remember how to exit out of a loop? We can use the break keyword. So if the user guesses the secret number, we're going to break out of the loop and then continue on with the program logic. So at this point, we'll extract sort of the comparison logic to see if the user has guessed the correct number after the loop. Because either it's going to end with the max amount of attempts, or we're going to break out early if the user has guessed correctly. So at this point, we'll have our comparison logic down here. If guess equals secret underscore number, then we'll print the win version of our message. And then we can simply say else. Right, either they've guessed the number or not. In this case, they've guessed incorrectly, or they've run out of guesses, simply. So let's say you're out of guesses, and then, we won't be cruel. We'll actually reveal the number anyway, so they'll be dying to know. The secret number is, and then we'll say secret underscore number. Let's see, why doesn't it? Secret number. Spelling mistake. There we go. Secret number. Okay, so let's just take a step back and review our code, make sure that everything looks okay. Then we say thanks for playing at the end. All right, I'm feeling good about this, so let's go ahead and save the file, and let's run this code and see how well it works. All right, great. So, I want to actually test this in 2 ways. So I'm actually going to try to guess incorrectly if I can. So guess too high. So I'm actually going to, even though I know 50 is too high, I'm going to incorrectly guess, just so I can test the logic to make sure that it won't allow me more than 6 tries. This should be my 6th one, I think. Yeah. Great. So this is sort of our red path here. Your guess is too high, you're out of guesses, the secret number is 4. So that correctly worked for exceeding the allowed max attempts. All right, so this time I'm actually going to try to guess it correctly. And so we'll be able to test the happy path here. So guess number 1, guess number 2, guess number 3, guess number 4, guess number 5. Okay, so I wasn't able to guess it anyway. The secret number is 92. All right, let's try again. Let's see if I can guess a number correctly. Too high. So I'm going to go, my strategy is to half my guess every time. Too high, too low. Okay, so I know it's between 12 and 25. So what should my next guess be? 19, 22, too high, 21. Yay, I finally got it. Okay, so you guessed 21, you guessed the secret number, 21, you win. Okay, great. So that means that the game is working correctly for both cases, whether I correctly guess or if I exceed the number of max attempts. All right, so we're going to move on to the final step, which is a sort of bonus enhancement of the game. But right now everything is working per the requirements. And so we'll try one more thing, bonus round, and see if we can add some functionality to our existing working game. All right, so let's move on to step number 5. This is the final step, and this is sort of a bonus round here. So we've got a fully functioning game. How can we improve it and make it just a little bit better for the user? So the requirement is to output the user's guess history, meaning all of their previous guesses, and the number of attempts taken at the end of the game. All right, so take a minute to think about how you might implement this. I'm going to start with the easy one, which is the number of attempts taken, since we already have that captured in the attempts variable here. So all we really need to do for that is to kind of output it here. You guessed the secret number, so I can say let's say in guesses, in so many guesses. All right, so let's go ahead and save and just try that to make sure that much works. Okay, so I'm going to say 50, 75, 65, 60, 58, 56, 51. Okay. You're out of guesses. So I didn't actually hit the clause that would output that. Let me try again. Guess is too low. Again, 75. Kind of again in the same general area. 60, 62, 64. Great. Finally I got it. On the last try, you guessed in 5 guesses. Okay, you win. So that part is working. All right, so the first part of the requirement is to output the user's guess history. So how would we sort of collect? We need to find a way to record all of the previous guesses. So what construct that we've learned earlier in this tutorial would you sort of employ to hold a collection of the user's guesses? All right, so if you guessed a list, I think that's a good idea. So that's exactly what we're going to do here. I'm going to create a new list called guess history, and I'm going to initialize it to an empty list, just like that. All right, so for each iteration through the loop, what we need to do is take the current guess and append it to this guess history list. So I'll go ahead and do that sort of at the top here. I'll go right underneath guess. So we've captured the guess, and immediately we're going to push it into this list. So if you remember how to do that, you can say guess history dot append, and then pass in the actual guess. So now each iteration of the loop, we're pushing that guess into the history list. Okay, so that by the time we're done iterating through all of these attempts, we've got a full list with all of the guesses. All the guesses. Okay, so at the very end of our game, we want to go ahead and output that. So I think what we could do is create a new function to then iterate over that guess list and output all of the guesses. So I'm going to create a new function called print underscore history. All right, that's going to take the guesses as a parameter. Okay, and I'm going to say print. I'll create a new line. You can create a new line in Python with /n, just to separate it from the previous text. I'm going to say guess history, and we'll end it with another new line. Okay, and we can use a for loop to iterate over the guesses. So I'll say for guess in guess history, and print the guess. Okay, so let's try that. Well, first we have to invoke that function. So we'll go right underneath it and we'll say print history. So we're invoking the print history function, and we need to pass in the list. Guess history list, just like that. All right, so let's save our code and let's run this and see what it looks like. Say 50 again, too low, 75, too low, 85. Oh, what happened there? Did I guess correctly already? Let me expand this a little bit so we can see it just a little bit better. You guessed, okay. In 2 guesses, so that's good. However, I'm not, oh, there it is, guess history. Okay, great. So it's showing my history of guesses. Thanks for playing. So a couple of things I think we can do, just formatting wise. I think what I'll do is I'll put another new line here just to give some space here, some vertical space before thanks for playing. All right, we'll give it an exclamation mark to make it a little more exciting. And then it's sort of, I don't know, I can't really tell what this means. So it would be nice if we could say like guess 1, guess 2, guess 3, kind of like that, right? To sort of enumerate the guesses. Otherwise it just feels a little bit random. So how can we sort of do that? How can we output, like, let's say we wanted to say which guess it was, like format guess number 1, right? Obviously that's not going to work because it's not dynamic, but you know, and let's say this is the variable, so we would use a formatted string, something like this, but we need a way to actually capture the index of each iteration, okay? So we're saying for guess in guess history, we don't really have a reference to the iteration, like 0, 1, 2, 3 for each time through this loop. So we might need a different strategy here. So one thing we can do, instead of literally iterating over the list, we can iterate over the length of the list. And that way we have a reference for each number of loops that we're actually iterating through. So if you're not quite with me, that's okay. Let me just code it out and we'll discuss it. So I'll say index in, instead of guess history, we'll say range, because now we're iterating over a fixed number of items. And do you remember how to get the length of a list? We'd call the len function. All right, so we're saying for index in range, and length of guess history should give us the actual length of the list rather than the list itself. So now, instead of guess number 1, 2, 3, we've got that information now in the index variable right here. And what does that not like about expected in? Oh, right, I forgot the in keyword. Okay. For index in range. Okay. And now, so we don't actually have a direct reference to the current item in guess history, because we're now, instead of iterating over that list, we're iterating over the length. So we're iterating over a number instead. So what we can do is we can reference guess history. Okay, and we can reference the current item by using index. All right, so now we're saying guess history at position whatever the current index is. Okay, so with this construct now we've got reference to both the number of iterations and the guess history list. Okay, so let's save our code and try this and see if this gives us what we're looking for. Guesses is not accessed, so I'm just wondering what's going on here. Oh, right, instead of guess history, this is guesses, since we're passing this in as this parameter name. So that's one thing I've got to change here. All right, that looks better. Glad I caught that before we ran the code. So just, yeah, make sure you update that. This is still referencing guess history, but vis-a-vis the guesses parameter here. Okay, so far so good. Too high, so we'll go to 25. Too high, we'll go to 12. Too low, so we'll start going in between here. Great, all right, so that looks a lot better. I've guessed correctly in 4 guesses. you win. We get our guess history, and this is just a little bit cleaner to see. Okay, my first guess, and you know what? It's 0 indexed, so we kind of have an off by 1 error, because the 0, that's, you know, makes sense to a computer, but not so much to a human. So how can I fix that here? I can simply say guess plus 1. So I could just increment that right here, just to make that a little bit more human readable, rather than starting at 0. Okay, so let's say 35, too high, 28, 26. All right, got it in 4 guesses. So yeah, that looks a little bit better. So now we're saying guess number 1 rather than guess number 0. That doesn't make so much sense. Great. Okay, so we've completed objective number 5, and our guessing game is now complete. So hopefully you enjoyed this. This kind of covered a lot of the topics that we've covered earlier in the tutorial. Lists, collections, variables of different types, casting variables from one type to another, for loops, while loops, looping over a set fixed number, looping over a collection, if-else logic, different kind of operators, printing out f-strings, formatted strings, functions, and calling functions. So that covered a lot of ground. Hopefully you enjoyed this final project. And with that, that concludes the tutorial. All right, guys, so that concludes the Python crash course. Thanks so much for watching. If you enjoy this kind of content, please consider subscribing to the channel. I've got some more tutorials in the works that will be coming out very soon. So until then, happy coding, and catch you next time.